Hey guys, let's go and jump into it. Multiplying and dividing rational expressions. Long title, let's break it down. Multiplying and dividing, you're very well aware what those do, right? Those operations. And rational expressions are simply, people, okay? Rational meaning a fraction or a quotient, right? Something over something. So then the question is, what are those somethings? What are those expressions? Specifically, polynomials. So with that, let's go ahead and jump into this. We're asked to simplify this rational expression, okay? Here's the quotient or a fraction, okay? That's something over something. These are two, polynomials. Now, let's go ahead and simplify that further. And then it says identify any y values for which expression is undefined. Alright, with these rational expressions, the first thing you want to do is identify where will I be, okay? So here's a question you got to ask yourself. Where will I be dividing by 0? Because this is illegal, right? So the fact that we can't divide by 0 in math is going to be very important. So that's the first thing I recommend you guys explore. So the quick approach to that is set the polynomial as the denominator equal to 0 and explore when that happens. Alright? So here's some old school problem solving. Will allow us to factor out a y and end up with this. Okay, from here I do know that if y equals 0, that'll make this whole expression 0, and if I've got y minus 2 equal to 0, that 2 would make this whole expression 0. So let me go and continue working this out. I'll add 2 to both sides and I get y equals 2. Now notice what I've done. Although I have solved this equation I've created, I've solved it for a reason, to find out the values that I do not want to actually make this into 0. So therefore, people, okay, in terms of this rational expression problem, I cannot allow y to be 0 and 2. If I do have 0 and 2, okay, let's plug in a 0, I'd have 0 minus 0, which would mean I'd be dividing by 0, and that's a no-no. If I put in a 2, I'd have 2 squared minus 2 times 2, which is 4. 4 minus 4 is 0, and I do not want that, okay? So I must exclude these from the solution set. Alright, so that took care of that. Let's go and simplify this. Now this problem here, okay, it is missing a square there. So, typos or whatnot, so let's go and continue. Now, when you look at simplifying problems like this, you should be thinking GCF, old school GCF. So, if you need to go look back at those videos, because I do go in detail, feel free to do so. Here, we're going to kind of jump the gun to keep the math nice and neat, okay? So anyways, if I look for a GCF up here, I do notice I can factor out a 4y squared, which will leave me a y minus 2. Okay, and down here, I notice that I can factor out a y, and I'm left with y minus 2. Alright, at this moment I see that this factor and this factor are similar, so they can divide themselves out. Here I do notice that he's got 2 y's, he's got 1, so I can cancel out 1. Okay, so he's got a 1, he's got 2, so essentially the 4 can come on down. I've got an extra y on top, and I'm done simplifying. Alright, let's go and continue. Once again, I'm asked to simplify what? A rational expression, specifically a quotient of two polynomials. Identify the x values for which the expression is undefined. So let's go ahead and do this part. Now this is something that we worked on, you guys got really good, and then you later showed to have forgotten this, so this is amazing practice, so please take advantage. So once again, I should immediately ask myself, right, my question is, hey, where will I be dividing by 0? Okay, so I set the denominator equal to 0. This is the whole factoring process once again. If you must look at some old videos, please do so. Here I'm going to get once again to the point, and I can set both of them equal to 0, and I notice that x would be what? let me not go too fast, I guess. I should set this one equal to 0. Okay, because if this whole thing is 0, the whole thing becomes 0. And I must explore where this is equal to 0. I can subtract 4. And I can add 2. So this is a solution to this mini problem, but in the larger context, I must remember that x cannot equal -4 and 2. Okay, once again, I must box that in. So I box it in because it's easy to kind of just ignore it, but it is important, just like this last problem we did. Right? We've simplified it, and we've made mention that the solution will not include these values. Okay? Very similar to what this one is. Okay? X cannot, equal these values. And now we simply simplify. Alright? Now as I look at this problem, I do notice that this one's not in the traditional order, right, with this one leading. So let's go and do that. Rewriting. Minus 3x plus 10 all over x squared plus 2x minus 8. Alright. Notice that there's a couple of things going on here, but just keep yourself organized and see if you can follow kind of like a pattern to our approach. Alright, we did talk about a while back about this negative leading coefficient. Alright, it is kind of cumbersome, so one tip from back then that applies now is kind of just factor it out. Alright, make sure everybody who follows has a change in their signs. Alright, and I'll rewrite the bottom. Okay. And now that puts me personally and a lot of other people at ease to no longer have a negative up here in the front. Okay, but he is still existent, so let's not forget him. I'm going to factor this bad boy out, and I'm going to produce a factor of what? Plus 5 minus 2. Alright, for some of you guys that might be going lightning quick, for some of you guys it's right on pace. Again, it's a personal challenge to go back and review this material if it applies to you. Alright, you'll have that much better experience tomorrow in class. Anyways, so here's that skeleton we used to talk about. I must now factor this, two numbers that multiply to give me him, add to give me this. So we'll go with plus 4 minus 2. And from here, let's go ahead and cancel out these like factors and bring down what's left over. Okay. Now, because I am technically done, I'm going to go and redistribute this negative back in there. I don't have to. This could be a final answer, but it is important to remember that that can happen, especially when looking at a final choice, let's say on a multiple choice test, and there it is. Alright. Alright, let's go ahead and move on here. What do we got? Alright, multiply the following, assume all expressions are defined. Alright. Assume all expressions are defined. Alright, so well, I guess what that's communicating to us is that we can assume that there is no issues with, let's say, dividing by 0, or the other no is what? A negative under the radical. Okay. So I really think they just want you to focus on the multiplication, so let's do so. Alright. One thing that I recommend is just kind of lump everybody together in terms of like terms, okay? So check this out. Alright? Because this is straight multiplication, I can just organize the top and the bottom. So I'm going to go 8 times 9 times, and I guess I can scratch them off as I use them, x to the 4th times x, and then I see he's got a y squared, and he's got a y squared. I just use them, so I'll scratch them off, and then I've got a z to the 6th. There's other approaches, but this one's nice, neat, short and sweet. Okay. Same thing here. Let's go ahead and it's 3 times 4. Use those up. Alphabetically, I now have a y to the 4th. Scratch them off, and z to the 3rd. Alright. And now what we can go and do is take care of combining these bad boys. So I got a 72, x to the 5th, y to the 4th. Notice how I'm just adding the exponents. This one's an invisible 1, and z to the 6th. Down here I got 12, y to the 4th, z to the 3rd. So notice that I've kept the top separate from the bottom. Now that I've cleaned it up as much as possible, now I can go and start working on the top and bottom. So I do know that 72 divided by 12 is 6. Boom, done. Okay, so I can scratch that off. Okay, x to the 5th, there's no x's on the bottom, so he will preserve the x to the 5th power. He's got 4y's, he's got 4y's, so they'll cancel. And he's got 6 z's, he's got only 3, so I'm going to be left with 3 on top. Alright, so yeah, essentially you've got 6 minus 3, and that's how I was able to get there that fast. Alright, divide the following rational expressions, assume all expressions are defined. So they don't want you to necessarily focus on any exceptions, any undefined values or anything like that. So that, once again, they're being nice. So this is the same problem as the last one, except for that an initial step. Let me describe that initial step. Alright, notice here we're dividing. On the last problem, we were multiplying, right? It had that little multiplication symbol. So here, since it was so straightforward on the other problem, I'm going to go ahead and make it a multiplication sign, but I'm going to rewrite this as its reciprocal. So the 25 was on top, it'll now go on the bottom, and this denotes the numerator. And that's a quick fix. Now let's do what we did on the last problem, organize our values. 5 times 3, done, done. I've got x cubed, and I got a y to the 9th. It's a lot simpler problem than the last one. I've got 3 times 25, done, done, x squared, and then the y. Alright, kind of silly for me to scratch them off. We're just trying to really keep it consistent. I got 15x cubed y to the 9th. I got 75 x squared y. And if we were to simplify this, we'd be left with, right, I do know that a common factor is 5. So I'll do it this way, since it's going to help me and it might help some of you guys. Alright, I've just identified a greatest common factor. And no, sorry, it is not the greatest common factor. 15 is the greatest common factor. So then, right, 15 times 1 is 15. 15 times 5 is 75. So then that's going to allow me to take 15. Right, let me rewrite it this way. 15 times 1, x cubed, y to the 9, and this one is 15 times 5, x squared y. Alright. See, this additional step's not necessary, but I think it's going to help some of you guys visually. So let's do that. Okay. 15 times 1 is still 15, but I've identified a greatest common factor. Okay, so we can chop that off. And the 1 comes along. He's got 3, he's got 2, so there's 1 extra on top. Done and done. Okay, this 1's been accounted for, but not the 5. So you see, the system's just saved my butt from making a mistake. And he's got 9, he's got 1, so there's 8 more on top. And there's the final answer. Alright. Let's go ahead and move on to this next one. It says solve and check your answer. Alright, I'll skip the check, but I will solve it here for you guys. So once again, I'm looking at a factoring opportunity. I hope you guys can look at these as opportunities yourself. Who knows, well, maybe we will check it, why not? Equals 11. And now, if I had to factor this lightning quick, I would produce a +6 and a -5. Now it does say check your answer. Now notice there's not that bit of information that assume all expressions are defined. Okay, so when in doubt, we need to once again ask ourselves the question, will I be dividing by 0? So real quick, let's do the math here on the side. X minus 5 equals 0. Add 5 to both sides. X equals 5. So there I must declare, whoa, this is a problem. So X in the bigger problem, okay, cannot equal 5. So I'm going to go ahead and, go ahead and continue solving this problem. I got X plus 6 equals 11. If I subtract 6 to both sides, I get X equals 5. And I'm like, wow, I just solved it. I feel awesome. But what did we just establish through this side work? That X cannot equal 5. So therefore, there's no solution. Now, if there was other solution, then I would just remove 5. But since 5 is the only solution, and I've declared 5 cannot be a solution, the whole problem has no solution. Guys, thanks for your time. Take great notes and have great questions for tomorrow. See ya.